have more habitat? Yeah, so that's why we plant native plants, definitely, because they're part of our natural habitat. Well, today we're switching gears a little bit, and we're going to talk about water, our water system, a certain part of our water system. And when we think about water, I had a question for you, like the earth that has a certain amount of water, right? Can we agree with that? Does the water move from place to place? It flows in streams, it evaporates into clouds, it goes down into aquifers underground. Like, the water has a lot of action, it likes to move around a lot, right? So, when you think about that water, in our brains, let's total up the total amount of water on the earth. Do you think that that amount of water changes or stays the same over time? What do you think? What do you think? It's kind of a tricky question. Kind of a trick question, kind of a tricky question. What do you think? That total amount of water on the earth, does like more come onto the earth, like from outer space, or does it just stay the same? What do you think?
More.
Almost everybody thinks that the water changes, that total amount changes, but guess what? It doesn't. It's the same amount of water, and it moves around in those systems we just talked about. It moves around in rivers and streams. It flows into the ocean. It evaporates into the clouds. It rains down onto the earth, right? But it always stays the same, that amount of water. So, are we drinking the same water that our ancestors drank?
Yeah.
Yes, we are. It's just moving and changing. It's cleaning itself as it moves through the earth, as it evaporates into the clouds. It's moving. It's changing. So are we drinking the same water that the dinosaurs drank millions of years ago?
Yes.
Yes, we are. And I love thinking about that. Like when I have a glass of water, I'm drinking some of maybe the water in this glass was drank by a Tyrannosaurus Rex. Could be. Is it possible?
Yes.
Absolutely. So as we think about water and how it moves in the world, we're going to talk today about, see if you guys have seen this word before. Watersheds.
Oh, yeah.
Raise your hand if you've heard of that. Do you remember we talked a tiny bit about it on the field trip? But that was a pretty exciting day, so maybe it was like easy to forget what we were talking about. But we're talking about watersheds today. And a watershed has a certain definition. Who wants to take a guess at what a watershed is? Like, what do you think a watershed is? I'm going to give you a hint. It's not a building. What do you think?
It's a big chunk of land that when water flows on it, it goes to one specific spot.
Bam, you knocked it out of the park. Okay, so let's write down this definition. A watershed is, do you guys have papers or like a little journal in your desk?
They do have a S journal. It's their science
Did
journal.
you guys get your S journal? Get a pencil. We're going to go ahead and write this definition down, okay?
The science part is the first part, the very beginning part. Go to the last page. Science should be at the very beginning.
Excuse me.
Nice job. Okay, looks like some of us have to dig a little deep to find them. Some people got them right away. You guys have other stuff in your science journals? You have a little bit in there so far? Cool. Ooh, good. Okay, awesome. Okay, so get a blank page ready in that S journal.
First, next empty page. That's
Good job. Okay. And go ahead and write watershed at the top of the page. Okay? Good
We
job.
talked about it a little bit before we went on our trip.
Oh, you did? Good.
Just
Okay.
started over there.
Perfect. Raise your hand if you already have the definition of a watershed in that S journal.
No.
If you already have the definition, you don't have to write it down. But if you don't have the definition, let's write it down together. Okay? A watershed is an area of land. Let's write this down.
Well, see if it's, hers might be different. She said if it's the same, you don't have to write it, but see what they write.
It's an area of land, so go ahead and write that down if you don't have it in your journal.
No, you're in the front part, which is the science. this is a little different. So go ahead and write it right under the other one. Oh, I forgot to fix this table. That's right.
Flows to a common point. An area of land where all of the precipitation flows to a common point. So as you guys are finishing writing that down, everybody knows what an area of land is. Can anybody think of an example? What is an example of an area of land? It could be any area of land. Yeah.
Say forest or maybe?
Ooh, a forest could be in a watershed. Absolutely. What else? A jungle? Sure. Yeah, what else? Ooh, like a place where a plane lands? Oh, like a plain land, like the Foster floodplain? Nice example. Good, a plane? Absolutely. What about our schoolyard? Could our schoolyard be in a watershed? What about our backyard at home?
Yes.
Yes, okay, good. So an area of land is any area of land. What about a desert?
Yes.
Yes. This was a trick question too. Deserts, do they have a lot of water in them?
No.
Do they have some water in them?
Yes.
Yes, because plants and animals, like a desert cactus or a desert fox, they couldn't live there if there wasn't some water. Okay, so there's just a tiny bit of water, but yes, there's water there. So an area of land where all of the precipitation, what's precipitation? Raise your hand if you can think about what it is or want to give me an example of it. Yeah. Oh, rain. Do we have a lot of rain in here in Portland?
Yes.
Do we have a lot of precipitation that is rain here? Yes. What's another type of precipitation? You might think of one that we really like these because sometimes it causes so this type of precipitation. Snow. Yes, snow. We love snow. Okay. What's another kind of precipitation? Also frozen. Comes in little ball shapes. Yeah. Yeah, ice or hail. Hail? Sure. Freezing rain also. So are there different types of precipitation?
Yeah.
Is it all made from water?
Yeah.
Yeah. Okay. So an area of land where all the precipitation flows to a common point. Who can think of what a common point might be where water could flow to? I'll give you a hint. We walked by one. We actually walked over one on our field trip. Who can think of this? What do you think? A creek. A creek. Great. A creek is an example of a common point. What's another example of a common point we could think of? Yeah.
The ocean.
The ocean. Is that a pretty humongous common point? Yeah, it's the biggest kind of common point when we're talking about watersheds. It's the biggest kind in the world, right? Because that's where most of the water goes. Okay. Ooh, a swamp. What a great common point. I love it.
A river?
A river? Absolutely. You guys have the idea. Okay, so we have our definition. Everybody put your hands out like this. So what we're going to do is we're going to learn a little hand signal for learning a watershed, okay? So let's talk about our definition. Say it with me again, the first part. An area of land where all of the precipitation flows to a common point. Let's do it again. All together we'll say it out loud. An area of land where all of the precipitation flows to a common point. Perfect. Okay, is this making sense?
Yeah.
Does it make sense enough that you think you could draw it?
Yeah.
With me. With me.
Yes.
Okay. All right. Let's start out with an area of land. Is Portland like super flat, or do we have some hills and mountains?
No.
Absolutely. So let's start out with some hills and mountains.
I can see it from here. Oh no. So we can draw as many as we want.
Okay. An area of land have an area of land here? Do we have some hills, mountains? Yeah, that could be an area of land. What could be in our land, do you think? Like, what could be on these hills and mountains, do you think? Like what?
Snow.
Ooh, snow could be. Okay, so let's make a little snowy, snow-capped mountain. I like that. What else, like, something a human could even build on a hill or a mountain
House.
to live in? House, right? Okay, let's draw some houses.
I'm gonna draw a house on top.
Okay. Yeah, you can draw your houses where you'd like. Okay. What about like a big type of plant that might grow on a hill or a mountain? What do you think?
Tree. Flower.
Ooh, flowers, sure. Show some little flowers.
Yay!
Okay. Do we have trees on there too?
Flowers. Why are the flowers bigger than the houses?
It's a crazy land we're on. You just never know what's going to happen here. Can we have some trees? Yeah?
Yeah.
Okay. I'm going to draw some crazy furry looking trees there. Okay. Now, okay, so we have some stuff on our area of land. So let's talk about precipitation. How could we draw precipitation? Yeah.
Draw rain.
Rain, okay. But where does rain come from?
Clouds.
Clouds from the sky. So should we start by drawing some clouds maybe?
Yeah.
Okay, let's draw some clouds.
This is clouds.
Okay, what kind of precipitation should we draw first? Raise your hand if you want to tell me. Yeah. Rain? Okay. Good choice. We have a lot of that around here. I'm going to draw some little raindrops coming out of my clouds. Okay. Okay. What's another kind of precipitation that could come out of our clouds? Yeah.
Snow.
Snow. Okay, let's draw some snowflakes. I'm going to draw a lot around that snow-capped mountain because I know that that snow is kind of building up over there. Okay, I've got a bunch of snowflakes. Okay. Any other precipitation, or are you guys good?
Hail.
Oh, should we draw some hail? Little dots like this. Or however you want, really. You're the artist. It's up to you. Okay, so we have some major precipitation falling out of these clouds here. I'm liking this. This is good. Okay, so let's go start again. Do we have an area of land?
Yes.
Do we have some precipitation?
Yes.
What are we missing?
Lake. Water. River.
Yeah, a common point, right? So maybe we could draw a river like flowing through the land like this. Okay, maybe some river over there. What's another type of common point that we could draw? Yeah.
A creek.
Ooh, a creek. Do we have a little creek like joining into a river? Okay, I like that. What's another common point where all this water could be flowing? Think about maybe the place I'm thinking about has it's very salty here.
Ocean.
What do you think?
The ocean.
Yeah, the ocean. Okay, let's draw the ocean. I'm going to draw mine over here. Actually, it just so happens that there's a surfer in my little ocean right there. I'm going to draw a tiny little surfer in there. Okay, can't see it very well, but she's in there. Okay, so there's our surfer in the ocean. Okay, what about is there any kind of common point you could think of where maybe the water doesn't flow but it stands still? What do you think? A lake? Yeah, absolutely. Let's draw a little lake up here. Okay, so we have an area of land where all this precipitation is flowing to a common point. But I have a question for you. Is all of our precipitation flowing to one common point?
Nope.
This is tricky. Eventually, water flows together in the ocean. But in our picture, let's start with this little piece of hail. Where is this hail going to fall?
In the lake.
It's going to fall in the lake. Where is this snowflake going to fall?
It's gonna fall on the
It's
ground.
going to fall in the mountain. And do you think it's going to creep up and over to the lake, or do you think it's going to flow down to the river?
So down the river.
Down to the river. Why? What force force is at work there? The force of gravity, right? Okay, so it's pulling it down there. What about this raindrop? What is it going to fall into?
The ocean.
It's going to fall in the ocean. So, how many common points do we have here?
3.
Yeah, we have 1, 2, 3. Okay, so how many watersheds do we have?
3.
We have 3 watersheds. Let's number them. This is 1 watershed. Here. 2. Here. 3. Here. Does that make sense?
Yeah.
I'm actually going to draw an arrow so I know where that little number goes, because that's where those are going. And so, but what about this snowflake? Like, which one is it going to fall into? Is it going to go in the lake or into the river? Probably not into the river. So there's something called a dividing line. And that dividing line divides what? What's a divide? What's a dividing line divided the watershed? It divides the land, and it divides 2 watersheds, right? Okay, interesting. So, ladies and gentlemen, oh, did you have anything else you wanted to share?
You forgot the sun.
What?
Sun.
Ooh, the sun. Oh, I'm really glad you pointed that out. Let's put a little sun in there.
How is there sun if it's raining, yelling, and snowing?
That's a good question. Where are our clouds?
It's crazy land.
They're below the sun. Is the sun always shining even if there are clouds?
Yes.
Yeah, it may not get to us very well because in a cloudy place like Portland, it might be blocking out some of the sun rays. But if you've ever been in an airplane, maybe you've flown above the cloud line and you've looked out and seen the tops of the clouds. That is spectacular. That's amazing. Isn't it beautiful? It's amazing. Yes, it's amazing. So, okay. Are you guys ready to hear about the next step? Because we have learned about a watershed. We've talked about it. We've written down a definition. We've done hand signals for a watershed. And we've drawn pictures for a watershed. The next thing that we're going to do is we are going to look at a watershed model. What's a model? What do you think a model is? Yeah.
It's like a little figure that you can look at.
Yes, a little figure you can look at. Absolutely. So our watershed model is a watershed. It's a figure. Is it bigger or smaller than an actual watershed?
Smaller.
It's smaller. Okay. Now, our watershed model that we have is pretty fragile. What does that mean when I say fragile? What do you think about that? What does that word mean? What do you think?
Like, it's easy to break.
It's easy to break. So, who do you think is going to be the ones touching the watershed model? Who do you think? You're right. You're pointing at her right here. And I'm also pointing at her right there. These 2 ladies can touch the watershed model, okay? Me and Julie. But can I ask a special favor? It is so tempting to touch it because it's the coolest thing ever. So can I ask a special favor not to touch it? Okay, awesome. So Julie's going to bring the watershed model in. And she's going to set it up here.
Is it gonna have houses and mountains?
And what if you get up here and, do you think the tallest student should stand right in the front?
No.
Probably not, because why?
Because they
Exactly. We want people to be able to see. So what I'm going to go ahead and do is I'm going to have you guys... What we're going to have you guys do is I'm just going to have you very calmly and quietly just walk right up here. Come on up. I'll move these.
It looks so weird.
We ordered it. There's a couple of nice watershed models. So as you guys have walked up and you're already starting to...
We already have some people that can't see, so
yeah,
we
let's make
gotta...
sure. And actually, some of you in the front, see what these guys are doing? It's good. It's good. You're you're going down like this. So do that because then the people in the back can see. Okay, that's perfect. Yeah.
Here now.
Nice job, everybody. Can you see okay? Can you see okay? So as we first look at the watershed model, I'd love for you guys to share some observations. What does that mean again when I say to share an observation? Like, what is an observation? Yeah. So it's something you notice. Absolutely. So who wants to share an observation, something that you notice? Oh, so there are tubes. And you're going to see these because what do you think that is supposed to be? What do you think?
So where the water goes in?
Yes. So in a building, are there things like gutters that collect the rainwater and then they shoot them out of a little downspout, a little tube? Yeah. Okay. What about these tubes? Do you think, what are those supposed to be? They're in the road. What do you think?
Like the how do you say, the sewers?
Yeah, like the sewers, exactly. And who knows what the sewers are? Like, what do the sewers do? Do you guys know about sewers? Yeah.
Assertive means, can you get down a little bit?
It's where the water, because
Right
all
in
the
there.
all the water flows against the curb, and then normally
So the water flows on the curb, and then it goes into little
into the
drains.
Yeah, and then
And the
sewer
sewer-
is underground, so the water doesn't flood the road.
Yes, exactly. So very good. So we have some sewers set up. What is this area over here? Like, what am I looking at here? Am I looking at a city? What am I looking at? A farm, absolutely. What about over here? What am I seeing?
City.
A city. Yeah, and like what could those be? Yeah.
A neighborhood?
Yeah, a neighborhood, right? What is this guy doing, do you think?
Construction work.
Construction work. Do you think that maybe these people are making new houses?
Yeah.
Making the neighborhood bigger? What's this right here? This little tiny patch of...
Trees.
Yeah, trees and forest, right? Maybe this is Kelly Elementary School. Could be. You never know. What about... So what's that creek again that's nearby? That's a part of our watershed here? Johnson Creek, absolutely. Can we use our imaginations that that's Johnson Creek?
Yes.
Can you remind me what Johnson Creek flows into?
Can
Can you remind me what Johnson Creek flows into? I'll give you a hint. It's a river. It goes through downtown Portland. What do you think? Yes, the Willamette River. And then what does the Willamette River flow into?
Oh.
Do you know?
Columbia.
Yes, the Columbia River. And then what does the Columbia River flow into?
The Pacific Ocean.
The Pacific Ocean. So, we have all sorts of interesting things. As we're kind of thinking about this area of land, I wasn't sure if you guys got the weather report today. Did you hear the weather report?
No.
Guess what?
What?
Rainy. 100% chance of rain. Are you ready?
Yeah.
Let's see what happens.
Can you spray some on me?
See what happens when it rains in our watershed.
Is it actually gonna rain today?
On our watershed model it is.
The water's going down. Aren't those buildings clear?
Yeah, you have a question? Yeah, go
I
ahead.
see the water.
Can you spray the ocean?
Yeah, eventually it goes to the ocean, right?
That's cool. And start planting the plants for the. I don't think rain sounds like that.
Oh, don't worry, those rain clouds are blowing in.
Those are
Here they come.
That's lightning.
Watch out, they might rain on you.
I got my arm wet. I didn't see anything go inside and come out of the
Ooh,
Those trees are
you want
kinda
to see this?
cool.
Let's see. Oh, there's a huge rain cloud over Kelly Elementary.
now I see it coming out.
There it goes. Yeah, okay.
Because they're-
So let's share some observations. What did you notice when the rain fell?
Oh.
Yeah, what did you notice?
So when the water went over there, it came through here.
It came through this tube and it flowed.
Where's it?
Exactly. Okay,
So
so
now
would
it's
you
an
say
ocean.
that the water tends to collect in smaller areas and flow to the bigger areas of water? Interesting. Okay. What did you notice? Yes, the tubes are collecting the water, and the water is going into what again? The sewer. But where does the sewer empty out into?
Wait.
Does the sewer empty out into? What do you think? Ooh, in the real city, the sewer, which are the pipes that kind of gather all the water, ultimately goes into the waterways. Did you guys know that that's true? When you're walking around on the street and you see those drains, did you know that those drains go down in the sewer? And that shoots directly out into the river? Sometimes it shoots into the creek, sometimes it shoots into the river. So it's something to think about. But anything that you see going down those little drains is going to go into those water systems. Okay, now there's something going on here. Do you think that this area of land, if we could use our imaginations and go back 1,000 years, do you think that this area of land, this city of Portland that we're looking at, do you think that it looks exactly the same 1,000 years ago? What did it look like?
Oh, what do you think? Full of dinosaurs and trees.
Super long time ago it would be full of dinosaurs, absolutely. But maybe let's say like a few hundred or 1,000 years ago, dinosaurs are gone, people are wandering the earth. But is it a city yet?
No.
It's not a city yet.
It's a town.
Do you think that there could be Native Americans here?
Yeah.
That's possible, absolutely. Okay. Do you think that there were big areas of land where, what are we seeing here? Like, are there plants growing right here?
Yes. It's like
Not here. It's dry. Is it? What are we seeing? Is it plants or soil? It's dirt and soil, right? Okay. So as people came and settled this area and they decided to make it into a modern day city, what kind of things did they build on it? What do you think?
houses.
Houses. What else?
They're starting to build a plant.
Yeah, this looks to me almost like, have you guys ever seen golf?
Yeah,
Looks kind of like a golf course, okay?
That kind of looks like the.
Ooh, what about here? People made a farm. Do you think that they had to cut down a lot of trees and plants to make this happen?
Yeah.
Do you think they changed the habitat a lot?
Yeah.
Okay, so guess what also started to happen? Some of these things that we're seeing are what we call exposed earth. That means there are no plants growing there. Now when there are plants there, what part of the plant is growing down into the earth? The root, right? And the roots, what do the roots do to that soil? Do they let the soil just blow and wash away, or what do they do?
They grip it.
Yeah, and they grip it. They hold it in place. So if there are no plants to hold the soil in place, what do you think happens to the soil?
It gets washed away.
It could get washed away. There's a name for that. When the weather washes away soil and rocks, it starts with, it could lead to a landslide. It starts with something, the word sounds like ooh, not evaporate. Good thinking. Because water evaporates. Erosion. Can you guys say that word?
Erosion.
Raise your hand if you've heard of that word, erosion. So what does erosion mean again?
That's good.
It's when
It's
the
cocoa.
water
It's
washes up
cocoa.
and-
It's cocoa.
When what happens?
when the water washes up and down multiple times and the dirt or rocks slowly gets
Yeah. So do you think, guess what? Rainstorm's coming. Watch what happens to that soil that's exposed.
Hey, this is crazy land. It turns mud. It's turning into mud. It turns into cocoa. Oh, it smells good. It's cocoa.
Because it's cocoa.
It's turning into mud. It's full of.
It's polluting the ocean.
My goodness, did we have some erosion on our hands?
Yeah.
Okay, did that erosion, like what happened? Like what happened in our habitat here, in our watershed? What happened? Yeah.
It polluted.
It polluted. It caused some what we call contamination, right? It made that water a bit muddy. Do you think that some other things might be going on in the city? Do you think that some of these cars that are driving, like have you ever seen a car and you've seen something kind of leaking out of it? A little bit of oil. Could be antifreeze. Could be windshield wiper fluid even. Could be gas. Sometimes cars might be a little bit leaky. Maybe as they drove, they left a little bit of that leakiness on the road as they drove.
Don't forget that car.
Do you think that tractors could sometimes leak a little
Yeah.
bit? Leak a little bit.
Oh,
What
yeah,
about
the
heavy
water.
machinery,
Yeah.
construction machinery? Yeah. Okay, that could happen for sure. So
Oh, no, but
City
it
water
rains
going through
again.
that tube at all.
there's something else that could be happening in this city. There should be some other things going on. What if our farmer decided, instead of using things like cow manure or chicken manure, which is a natural way of fertilizing plants, what's fertilize mean? What does fertilize mean?
Like spreading to help it grow.
To help it grow, right? So people want to make plants grow better. That's fair, right? That's a good thing to do because we need our food, right?
They can also
But they're
use different stuff and it's not good for the plants when it washes off.
yeah, and so there are two different kinds of fertilizers, you guys.
A
Fertilizer.
natural kind and a bad kind.
Okay, so there's a natural kind, and then there's a kind that we make, that like scientists make in a lab, right? So the natural kind actually just decomposes into the earth, and it actually makes for a really, really healthy ecosystem. But then there's the kind like Miracle Grow and things like that that you could actually squirt on something like, could you put it on a golf course?
Yeah.
Why would you want to put it on a golf course?
To make it look green and
To make it green and perfect. Could you put it in a yard?
Yeah. Put it on the house.
Put it
Yeah, it accidentally got on the house.
Could you put it in a farm?
No, put it in the ocean. Yeah. Yeah.
What about in the pasture to make the grass grow for the cows?
What about the ocean?
What about by the school to make the school
Yes.
grow pretty?
How about the
Okay.
one of them
So this is fertilizer that is what we call synthetic. It's the one made in a lab. It's not the natural stuff.
synthetic growth.
And sometimes there can be other things
Is that
happening
real ink?
too.
No,
What's that?
poison.
What about if you took your car to a car wash and they used a whole bunch of soap on it?
Poison.
Okay, it could be soap. Right?
Poison the
Soap on there.
animals.
What about, trying to think, what other kind of chemicals? Ooh, what if we were like washing our driveways or something? Chemicals to make our driveways washed. Let's wash that.
They clean house.
Okay.
What about the ocean?
Now, guess what? Weather report's in.
Oh no.
It's about to rain.
Look at these.
What is that? Look at the ocean. Oh! Ew. Pollution. Oh, spread it. Oh, it's getting die! The farm's
Oh my goodness. Okay.
I want to take a bath now.
So this is an interesting thing that we have seen happening here in our watershed. Who wants to make an observation about what happened when it rained? Yeah.
The farm's flooding.
Oh, so some of the water's flooding a little bit. That could be. Yeah. So this is interesting. Did you hear what he said? Because not only is it affecting some of our streams, but is it affecting our bigger rivers?
Yeah.
What else could it affect?
Our ocean animals? Our agua.
Animals, the water. Do we rely on water to drink?
Yeah.
Yes, we do. What about the animals? Do the animals rely on
They'll
water?
go over here and drink.
Okay, I'm going to ask you to use your imagination. Are you ready?
Yeah.
Okay, let's turn it on full blast here. Okay? Because some of us in this classroom
Laying on me.
are actually little teeny bugs. And we're little teeny bugs and we live in the water. And we have little things that help us breathe underwater. What are those called?
Lungs.
Gills. They're different than fish gills. They're like these little feathery gills. We're little bugs. And we're swimming around in there. And we're swimming around. And do you think that we like really clear water?
Yeah.
Or do you think that we're like, oh cool, it's getting all muddy and filthy and contaminated? What do you think?
Yeah. You die.
I think we like clear water. Okay, so maybe we're not doing so hot because our water's starting to get affected. Well, you guys are frogs. And you also live in the waterway with us. And guess what you eat?
Flies. Flies. Bugs.
You eat these bugs in the water.
Ew.
And guess what? How do you think frogs actually have really sensitive skin? How do you think their skin reacts when they get chemicals on it?
Like bubbly and burning.
Yeah, it does not feel very good to them. So they're starting to get a little unhealthy.
Like
And you guys right here, guess what you are?
Fishes.
You're fish. And guess what you like to eat?
Frogs.
Frogs.
Yes.
Ew.
You guys are fish. You guys are fish and you like to eat frogs, okay? But do you think the fish like it when the water is really dirty like that?
Yeah.
Okay, and you guys are actually some birds of prey. You're bald eagles and you're ospreys. Now think about this for a moment, you guys. What the little water bugs that everybody, do you think that these guys ultimately rely on us little water bugs?
No.
Yeah.
I'm a perfect
Yeah.
They do, because you eat the fish eat the frogs eat the bugs. All of a sudden, the bugs start dying because the water's too dirty.
Then the frogs start dying.
Then the frogs start dying.
Then the fish start dying. Then the
And
seahawks.
then you don't have anything to eat. And let's just say that you as a peregrine falcon, you decided, you know what, I'll just eat some other birds. Well, the birds have been eating some bugs in here. And guess what? Sometimes when the water's dirty and these different chemicals, like let's say some of the chemicals, like maybe the oil, or if we were using a chemical like called DDT, and that's a chemical people used to use to kill bugs on plants. Guess what can happen? It's not just that the chemical will kill like an animal right away. Something like DDT, guess what it does to you guys? When you go to lay your eggs, it makes the eggshells super, super, super fragile. And that's like, okay, well that's no big deal, right? So what if the eggshells are fragile? Well, how do birds keep their eggs warm?
They sit on them.
So guess what happens when you go to sit on your babies? They squish the babies, and in one generation, you could kill out all the birds. So these chemicals can affect the habitat and the ecosystem and the animals in many, many different ways. So I have a question for you. Do you think it's pretty normal to have these kind of problems in a city? It's actually pretty normal, you guys. It's a problem that most cities have. But what can we do in our cities to help these problems? What can we help? What can we do?
Take away the car wash.
Well, we could take away the car wash, or could we use soap that doesn't hurt the animals?
Yes.
Sure we could. Absolutely. That's something I decided to do with my car. When I wash my car, I only use soap that doesn't hurt animals because I know that soap's going to go where? In the sewer, into the waterway. Okay, what else could we do? What's another thing that we could do to help? Yeah.
We could get a whole team together and then just clean the water.
Ooh, did you know that there's a big project in Portland going on to help clean the water in the Willamette
That's
River? It's
how
been
I got
going on for
That's
years.
how I got that idea.
Very nice. So you've been paying attention to what's happening in your community. That is awesome. Okay, now what's another thing that we could do? Yeah.
We could just like make a little shelter for people, for like animals and stuff.
Are you thinking of creating habitat?
Yeah.
Because I think that's a fabulous idea. So if we were to create some habitat for animals where they could be safe and they could be clean, would that help them?
Yeah.
Question to you, what did you do at the Johnson Creek floodplain on the field trip? What did you do? Yeah.
Plant trees.
You planted trees. Do you suppose you were creating habitat?
Yeah.
Absolutely. Now, do you remember how at the Johnson Creek floodplain, what had people done to the wetlands? What did they do in the past? Who remembers? What did they do?
Polluted it.
Well, there was some pollution, but they built something on that wetland.
Houses.
They built neighborhoods.
Yeah.
They built neighborhoods, and so
My great grandpa used to live there when they had the houses there before they tore them down.
interesting. Wow. So he probably saw some of that flooding that happened in the winter,
Yeah,
and so
happened a lot.
there they decided this just shouldn't be a neighborhood at all. We're going to turn it back into a wetland. But a lot of neighborhoods, do you think they're going to stay put? Yeah. Most of our neighborhoods are going to stay put. So if our neighborhoods are staying put, what could we do? You guys did it at the Johnson Creek floodplain. What could we do around these houses to kind of help hold some of the soil in,
Fertilizer.
create some habitat? What do you think?
Use normal fertilizer.
Oh, what a good one. You could use normal fertilizer like chicken manure and cow manure. Or what could you literally put into the ground? You did this on your field trip. Trees, plants. You can plant native trees and plants. And do you think that they help hold the earth in? Okay, so that's good. So we're not going to have erosion going on. But guess what they also do, which I think is kind of amazing. Guess what they also do?
They make oxygen.
They do make oxygen, and that is amazing. And they also can help to clean some of these chemicals so that they don't get into the waterways. So if everybody planted some native plants in their backyard, do you think we'd be in a better shape? Yeah, absolutely. And if we start cleaning up our watershed, what do you think will happen? Do you think those little critters? Yes, beauty comes. Absolutely. And what happens with those little critters?
They come back to life.
Did you know that they actually come back?
What?
Did you know they actually come back?
Wait,
They'll
they
come back.
from the dead?
They don't come back from the dead. They come back from other healthy watersheds, and they come in and they say, hey, this is a nice place to make a home. I'm going to come and live here now. So that's pretty cool that we can reverse that, isn't it? We can make it back to a really nice, healthy habitat. Okay, you guys did a great job. What we are going to do now is clean up, but I know the fun part is watching me pull the plug on this.
Oh.
So let's pull the plug.
Go down. No, it's the plug to all the water going away. Wait, what is this? Is that like a water pool?
That's actually a water treatment plant.
All the water's going away.
I see the source down here.
Okay, thank you so much for your attention today, guys.